Okay, starting us off in Chapter 8 with our chemical reaction basics. This video here is going to walk you through just making sure we know how to write them, what the symbols mean, and then we're going to end up making sure we're balancing them properly. If you remember from our one of our first labs, chemical reactions, we know that they're happening when we have one of these 6 things going on. Bubbles, an odor given off, a color change, a temperature change not from heating or cooling, a solid formation, a change in pH, or light, heat, or sound being given off. Any of those means we're having a chemical reaction, which means something new is being produced. Okay. When we are writing reactions, you want to have this in your notes. These are the must-haves. The equation must be factual, which means it must be able to happen. Chemical formulas must be correct. Remember our naming. Okay, and when we come to balancing, it's become very, very clear why it's important to have them correct. Use your skills, and also remember Hunkelbrief or Brinkelhoff. These are what we call your diatomics. Okay, diatomics, which means bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine will not exist in an equation by themselves. There will be no F. It will be F2. There will be no Cl. It'll exist as Cl2. So the diatomics is a molecule of 2 atoms together. And the last bit we're going to touch on is they must be balanced. Okay, we must balance them using coefficients, which are different than subscripts. We'll touch on that. Okay, we got to make sure the left side and the right side have an equal number of moles for each atom. There's multiple ways of sort of reading it. There's the word equations, where someone can explain what's going on. The top one is actually kind of our middle or swing state, where zinc plus hydrogen chloric acid yields hydrogen and zinc chloride. Or as said here, zinc and hydrochloric acid react to yield hydrogen and zinc chloride. So if you see an equation like this, you want to transfer it into this form, and that form is going to help you get to the formula equation. Now, this arrow here means yield. It does not mean equal. Alright? Because left and right side are not equal. They are different. When you put the left side together, it can give you the right side, but they are not equal. This is the formula equation here. So we went from this guy here up to the formula. Alright, and this is where we have to make sure our naming is on point. We've got our zinc. We're going to talk about what this guy is in a second. Added to our hydrochloric acid yields hydrogen. Ooh, there's that diatomic in our Brinkelhoff, which starts as H2, and then zinc chloride. This 2 here exists because if you remember, zinc is +2 and chlorine is -1. So to balance out this compound, you got to have 2 chlorines for every 1 zinc. It's different than this here, which is your coefficient. Just put co there. It's the coefficient. When we come to balancing, we're going to talk about that. The symbols you want to know, you want to get these in your notes too. The arrow means yield. Just spoke about that. S, the little S pass will tell you it's in its solid state. This is actually a cursive L. That's how we signify liquid. AQ is aqueous, which means it's a solid dissolved in water. G is gas. And then if you have a delta or heat written over the yield sign, that means that heat was added into the system to help the reaction go. You'll also see different names written over or electricity written over the yield sign. All that means is something else was added in, a catalyst or something like heat or electricity was added into the reaction to help it go. Alright, so when we do some practice, we're going to bump through some here right now. We're not going to worry about balancing. We're just going to worry about getting them written down properly. For each example, press pause, try it on your own, and come back and see if you got it or see where you went wrong. Sodium reacts with chlorine to yield sodium chloride. So let's write that out in middleman style. Sodium plus chlorine yields sodium chloride. Now we're going to pull out our naming skills. Okay, sodium, Na, hanging out. Chlorine, it's part of that Brinkelhoff, so we have to have Cl2. And that's going to yield sodium chloride. Now let's make sure we got our charges. Sodium is Na plus, chlorine is Cl minus. Put them together, out of 1 to 1, you get sodium chloride. This is good for now. It's not balanced, however. It's not done. When we learn balancing, we're going to fix this one up, but it's good for now. Decompose is another type of reaction that happens, decomposition reactions. Here's an example of a decomposition reaction where you actually have looking like more on the right than the left. It's when something on the left breaks down to its pieces in the right. Hydrogen peroxide decomposes to yield oxygen and water. Let's do hydrogen peroxide. If you remember, hydrogen peroxide is an H, which is a plus. Peroxide is an O2 minus 2. So if we do our cross there, hydrogen peroxide looks like H2O2. Decomposes, which means it breaks down to yield oxygen, O2 because of Brinkelhoff, and water, H2O. So a reaction can look like this. You can actually have one compound on the left and multiple compounds on the right in a decomposition reaction. Last one for just naming, a little bit more difficult. Copper reacts with silver nitrate to yield silver and copper 2 nitrate. So copper, we've got our Cu2, happy by itself, reacts with silver nitrate, AgNO3. Now remember, silver is Ag plus and nitrate NO3 minus, so they're happy. And that yields silver, Ag, and copper 2 nitrate. This is important. Remember, we stressed those before. Nitrate, again, NO3 minus, copper, Cu plus 2. So if I do my cross, I actually have to get copper, parentheses around my nitrate, 2. All right. Again, this is not balanced, but it is written correctly for our purposes right now. Okay, so now into balancing equations. The first step of balancing equations is what we exactly just did. Write out the formula and write out the skeleton. Okay, remember always Brinkelhoff or Hunkelbrief. Make sure that you have your diatomics listed properly, and also make sure that everything is named properly. If you've got one thing named improperly, it might mess up the entire balancing and not even mention that you've got the wrong molecular formula in there. When we're balancing, keep your polyatomics together. There is one example where we're going to split up carbon, hydrogen, and oxygen. That's okay, but for the most part, keep your your polyatomics together. Look at your metals first. Solo elements, save them to the end, and then hydrogen and oxygen, also save them to the end if you can. That will help you out a lot. Let's do some practice. Okay, so remember this decomposition reaction. We've got hydrogen peroxide breaks down to yield oxygen and water. Now here's what we want to do, and this still gets done by a lot of high-level chemists, just writing them out. We want to write down all of the elements in this equation, sort of put the elements down the middle under the arrow so we can balance out the left and right. What's on the left wants to equal what's on the right for each element. Okay? So first, write down what you have. I've got 2 hydrogens on my left and 2 oxygens on my right. Or excuse me, 2 oxygens on my left. On my right, I've got my 2 hydrogens here. I've got 1, 2, 3 oxygens here. Okay, so I'm going to have to balance out my oxygens. Now what I can try and do, and sometimes starting off with guess and check until you start getting the flow is totally fine. So Let's add a 2 on the outside here. That's going to go ahead and bump up my, hydrogens to 4, 2 times 2, and my oxygens to 4. Well, now it looks like I've got it off balance, but let's see. If I add a 2 out here to balance my hydrogens, I'll make my hydrogens into 4. And look at that. 1, 2, 3, 4 oxygens, because this is a 2 times that 1. And I go from 3 to 4, and I can say I'm happily balanced with this equation. Okay? Let's try this one. Again, press pause if you want, try it on your own, and come back and see if you got it. I've got 1 copper on my left, I've got 1 silver on my left, and I have 1 nitrate on my left. On my right, I have 1 silver, 1 copper, but 2 nitrates. Okay, so let's attack the polyatomic first. It's the one that is not balanced. If I put a 2 outside of here, that gives me 2 nitrates, but it also gives me 2 silvers. When I look up here, that's an easy fix. Silver solo over here, so I put a 2 on that side. I've got 2 silvers this side. And I've got 1, 2, 2. I've got a balanced equation. A little bit tougher now. I've got polyatomics and then also 4 different elements, but it's the same exact process. Start on the left, 2 aluminums. Okay, let's keep my sulfate together, SO4 here. I know there's another oxygen here. We'll just keep the SO4 here together. So 1 of those. Let's only count this oxygen. Make sure you don't make that mistake. If you're going to keep this sulfate together, don't overcount this oxygen here. That's only 3. Okay, and then hydrogen, I've got 2 of them here. I've got aluminum, 2 on this side. That 3 tells me I have 3 sulfates on this side. Okay, 2 hydrogen, and only 1 oxygen. Okay, well, let's start with my polyatomics first. I've got 3 on this side, on my right, so let's add a 3 over here. That'll give me 3 sulfates, but it also will bump up my hydrogens to 6. Okay, aluminum's balanced, sulfate's balanced, oxygen is not balanced, and hydrogen is not balanced. But if I look at this, 3 oxygens to 1 oxygen, 6 hydrogens to 2 hydrogens, that's looking like both have multiples of 3. So if I put a 3 outside my water, that'll give me 3 oxygens and 3 times 2, 6 hydrogens. And I've got myself a balanced equation. Here's an aluminum with zinc chloride into zinc and aluminum chloride. Okay? Let's look on my left. 1 aluminum, 1 zinc, 2 chlorine. 1 aluminum, 1 zinc, 3 chlorine. In a situation like this, you can actually look at it and balance with a similar way of balancing charges. So if I do my cross, if I put a 3 over here and a 2 over here, this 3 will give me 3 zinc and 6 chlorine, and it'll give me 2 aluminum and 6 chlorine here. And this is why we keep the solo atoms by themselves. If I've got 2 aluminum on the right side, I can go over, put a 2 here, that'll give me 2 aluminum, balance that. I've got 3 zinc on my left side, I can just put a 3 there to balance out my zincs. Now I've got balanced aluminum, balanced zinc, and balanced chloride. Even tougher now. This is the one where we have a polyatomic, okay, on this side here, but it's broken into binaries over here, covalent, covalent, ionic, so we can't really keep it together, so we have to split up the carbon, hydrogens, and oxygens, even though on the left side there's 1, 2, 3 different spots with oxygen. That's going to make it even tougher. take your time with this, guys. If you don't get it at first, it's no problem erasing it all and starting over and doing your best till you get it. On my left, I've got 2 sodiums. I have one carbon, and 1, 2, 3, 4 oxygens, and only 2 hydrogens. Whereas on my right, I have 1 sodium, one hydrogen, 1 carbon, and 3 oxygens. Now remember, let's start with our metals first. So let's look at the sodium. If I put a 2 here, okay, I can balance out my sodium, but it also changes. It gives me 2 carbons, it gives me 2 hydrogens, and it gives me 6 oxygens. So I got my sodium set. I want to look at my carbons, oxygen, and hydrogen. Let's keep, actually my hydrogens are balanced at 2. So definitely, let's go to my carbon dioxide on my left here, because that's where the carbons are. Remember, if you leave your oxygen and hydrogen to the end, this is going to help you anyways. So let's see, if we've got 2 carbons on my right and 1 carbon on my left, I can balance that out with a 2 here, and that gives me 2 carbons, 4 oxygens here, but don't forget to add these in. So 1, 2, 3, 4, 5, 6 oxygens. And look at that. I have myself a balanced equation that's actually pretty tough.